All right, this is More Beach Adventures. It's page 212 in your workbook. After spending the day building sandcastles, Oceana wants to take an evening walk with a friend along the shoreline. Oceana knows that one stretch along the shore is quite rocky. At that point, the rocks jut into the ocean. To walk around them, a person has to follow a path that is 14 feet below the average waterline. If Oceana and her friend don't want to get wet, they need to take their walk when the waterline is 14 feet or more below the average waterline. What is the time period during which they can take their walk? Okay, so that looks like the question we need to answer. But there's more information before we do our problem. So it says, remember that the position of the waterline over the course of the day is given by the equation W of t equals 20 sine of 29t. I'm going to just put that in a box because we're going to use that right away. Where the distance is measured in feet, and t represents the number of hours elapsed since midnight. Okay, so here's Oceana on the beach walking with her friend, and they want to just avoid rocks, and so the thing they need to do to avoid the rocks is wait till the tide line gets below 14 feet. Okay, so then it says, what is the time period during which they can take their walk? The way that we're going to solve this one is a little bit different than what we did yesterday. Yesterday, we figured out that we could model our average tide line with our sine function. I'm not going to label the axis right now, but we knew that the high tide is going to be 20 feet, the low tide is going to be negative 20 feet, and that all just comes from knowing that the 20 in front of the sine is your maximum and the negative version of that is your minimum. Oh, let's write that up here. W of t equals 20 times the sine of 29t. Okay, and 14, let's see, that's probably 10. 14 will be somewhere in there. So here's what we're looking at, 14 feet below tide line, which means that the time that the two of them would have to go on their walk is the time from here to here. So the question is, what is this distance? If you watched the previous video to this one, the sandcastles video, you actually already answered a question that's nearly identical to this, and we answered it by guess and checking. We said, well, what value of t would get us close to this negative 14? I hinted in the last video that today we were actually find an exact time, find a way to solve the exact time of this problem. And one thing I want to point out to you is that we can also have negative answers because we're just modeling this cycle. Oh, yeah, that looks a little funky. But we're modeling this cycle, and so we can say, well, also backwards in time, we can go this way as well. And when we solve for it, the time that our answer time that we're going to get is going to be negative, which means it's a previous time that we were looking at. And that's okay, because I don't think it tells us specifically in this workbook what we should have, and I want to show you all how to solve exactly for the time. So what we're looking for is we're going to use this function, and we're looking for the first time when the tide is going to be at negative 14 feet. So let's do that. So we're going to set, if this number represents the water line or the tide line, we can actually set this part equal to negative 14. And we're going to say negative 14 is equal to 20 times the sine of 29t. So all we did was we just set the water line equal to negative 14, which is exactly what we're looking for. And in this one, you're just going to use your regular algebra steps to solve for t. And so since t is grouped in these parentheses inside the sine function, we have to start by doing inverse operations, and we're going to start by doing the opposite thing of this times 20 right here. The opposite thing of times 20 is divide by 20. So we're going to divide both sides by 20. And I'm going to actually leave it in this format. But these two 20s will cancel out. And so then we're left with negative 14 over 20 equals the sine of 29t. Now you may or may not know what to do right here. This is, I think we tried it once in our class several weeks ago, but this is new, kind of. It's not used frequently. Here we've got a sine function that has something that has stuff in it, including our t. We need to get rid of this sine function so that we can start to manipulate our t. The way that we do this algebra stuff is we use inverse operations, right? The inverse operation of times 20 was divide by 20. So when we did times 20 and divide by 20, it canceled them out here. And then since it's an equation, we have to divide by 20 on both sides, which is where this 20 over here came from. So think of it as a scale. If you divide both weights of a scale by 20, and if they're equal to each other, then they're still going to be equal to each other. So then the question is, what's the inverse operation that we can use for the sine function so that when we do the inverse sine function, both sides of the scale are still going to be equal? The answer to that is, actually, we are going to use the inverse sine function. And it looks like this. We're going to take the sine inverse. If you have an exponent raised to the negative 1, that's a mathematical symbol that means inverse. We're going to take the sine inverse of both sides. So it's going to look like this. Negative 14 over 20 is equal to the sine inverse of, and we're going to take the sine inverse of this side, the sine of 29t. Okay, so let's just look at what we did really quick. So you can see that the equations, or both sides of the equations are just inside this new sine inverse function. And let's see what that does. So for this side, the sine inverse and the sine function cancel each other out. So then when we rewrite this side, we're just left with 29t. When we're on this side, this is exactly what we got, the sine inverse of negative 14 over 20. Okay. Now, the last thing we can do is here we've got t times 29. The inverse operation of times 29 is divide by 29. And we have to do that to both sides of the equation. Once we do that, our 29s cancel out. And this is what we actually end up putting in our calculator to solve for t. So I'm going to show you how to do that. Clear all. Okay, you can see the calculator. So there is a button on your calculators called the sine inverse button. If you're using this Desmos Scientific Calculator app, which I recommend, this is how you find it. You click the functions button and it looks like this. In your other calculators, you're going to have to look to find what the sine inverse looks like. If you've got an iPhone, you'll have to turn it sideways. If you've got a TI-83, our black plastic calculators, it's usually the second sine button. Androids, I think you push the down arrow and there's an INV button. Okay, so anyways, so there we go. So sine inverse of negative 14. Let's see, then back to main. Negative 14 divide by 20. And then close that. And then divide by, oh, can I pause this? I can't pause this. That's okay. Then divide by 29. Boop, boop. And that's our answer. At negative 1.53 hours is when the tide equals 14 feet. Negative 1.53 hours. Meaning one and a half-ish hours before midnight. So what would that be, like 10:30? No. Am I doing math right? Yeah, 10:30-ish. So that's going to be, let's see, should we draw our picture a little bit clearer? Let's draw our picture a little bit clearer. So now we're going backwards in time. Here's our negative 14. And we know that, oh, and here's our 0 line, that's negative 14. And so we know that this point, it's at negative 14 feet and it's negative 1.53 hours. Okay, then our next question is, well, how long is it to get all the way down, right? And we know that our minimum is negative 20 feet. And we're going to solve it the exact same way. So check this out. We're going to say that negative 20 feet is equal to 20 times the sine of 29t. And we're going to solve for t the same way. I'm going to do it a little bit quicker this time. But we're trying to isolate the t, and so we'll divide both sides by 20. These 20s cancel out. So, and then also negative 20 divided by 20 is just negative 1. So we get negative 1 equals the sine of 29t. Then we take the sine inverse of both sides. So then we've got the sine inverse of negative 1 is going to equal, and then the sine inverse cancels this sign, 29t. And then we can divide both sides by 29. Then we get the sine inverse of negative 1 over 29 equals t, because those 29s cancel out. So let's figure out what that time is. Clear all. And we're going to find, let's see, oops, so we can see everything here. So sine inverse, function sine inverse of negative 1, close parenthesis, divide by 29 is equal to negative 3.103. And that would be hours, right? And so there'd be 3 hours before midnight is when it was right here. So negative 3.10344, zaba, so on and so forth. Okay, so then the question is, how much time do they have? Well, we know that these graphs are symmetric. So the distance from here to here is going to be some distance x. And the distance from here to there is going to be the same distance x. So if we can find the distance between these 2 points in time and then double it, right, because this total distance is just the length of 2 x's, then we can figure it out. So let's do it. We can just take this number and subtract that number, and that'll give us our answer. So let's do it. Negative 3.10344 minus negative 1.53. When we do minus negatives, that'll turn into a positive, and this can confuse a lot of people, so make sure and keep your signs when you start this equation, and then adjust it as you progress through. So we're doing negative 3.10344 times, can I just click on this and it brings it back? Boom. Sure, no, that seems like a lot of work. Okay. Negative 3.10344 plus 1.53 is negative 1.57 is negative 1.57 hours. And since we're really just asked for what's the amount of time we would have, we can ignore the negative sign on this answer, right? Because this is just saying from here to here, you'd have negative 1.57 hours. But if you went from there to there, you'd have a positive 1.57 hours. So we're going to say that the amount of time we have is, and if we round that, we just say it'd be 1.6 hours is the window that these two have to go on their walk. Okay. The next part, it says, question number 2 says, while she builds sandcastles, Oceana likes to amuse herself by looking for numbers that have a sign of a given value. Here are 4 problems she thought about recently. In parts A and B, find exact values for theta. In parts C and D, give theta to the nearest degree. Your solution should be between negative 360 and 360. So it says find 3 other values of theta other than 15 degrees such that sine of theta is equal to the sine of 15 degrees. Okay, so first of all, our answer should be between negative 360 and 360. So if we're thinking about that, I'm going to just draw a sine graph, and with one positive one, so this is up to 360 degrees. And then if we go the opposite direction, right there is negative 360 degrees. And so this first one asks, find three values other than this one that this equals this. So the way that we do it is we say, well, isn't that just the sine of 15 degrees is going to be the height of this graph at 15 degrees. We know that right here is 90 degrees. And so then right there, halfway through is going to be 45. Sine of 15 is just barely, right? So this right here, we might label as 15 degrees. And the question is, what other points on this graph, what other degree values on this graph have the same height? So if we look at this, we'd say, well, that would be that point. It would have to be this point, and then it would have to be this point. Okay, our first question is, well, what would this point be? We know that this is 15 degrees after it was at the 0. And then that means since it's symmetric, this one must be 15 degrees before the 0. Well, what degree value is this 0 at? That right there is 180 degrees, right? Because it's half of a period. So then what's 180 degrees minus 15? That's what our answer is. So this would be 180 minus 15. And then so that would be, what is that, 165? So that's right. Oops, this is for A. So it's theta equals 165. Now, we actually have all the information that we need to answer the other two quite easily. Oh, look at that, I zoomed in. We know that in these sine graphs, a period is going to be 360 degrees, right? From here to here, that's 360 degrees. Which means, well, what about like from the beginning to the beginning again is also 360 degrees. Which means that our distance from our 15, right there at the beginning of this peak of this hump, is going to be 360 degrees bigger than this point right here. So this point right there is just 15 minus 360. And that's going to be negative 345 degrees. This one, in a really similar way, now we just start here and take away that 360 degrees. So this one right here is actually going to be 180 minus 15 degrees minus 360 degrees. So let's see. That would be, which would be 165. Oh man, actually this math feels like so much math to do. Oh, okay, let's do it. Let's do it on a calculator. 180 minus 15 minus 360. That's negative 195 degrees. Let's see. The next one says find three values of theta such that the sine of theta equals the negative sine of 60 degrees. What is the negative sine of negative sine of 60? Is negative 8.6? What's the positive sine of 60? That's just positive 8.6. So then in that case, you might find 1, 2, 3, 4 spaces like that, in the same way we just did. I'm not going to do the rest of these, but I would say do them and practice them because they'll help on quizzes and really just in your overall understanding of this work. But that's our work. Thanks for watching. Hopefully that was helpful.